Let's look at an enthalpy diagram to better understand heat of formation, delta HF. Carbon in the graphite form is the most stable form of carbon, and so by definition, we set its heat of formation as 0. Okay. Remember that enthalpy is just another word for stored energy, and on an energy diagram, higher up here means less stable. So that's why carbon is down here at 0, because it's the most stable form of carbon. Here's another form of carbon, diamond. Diamond's not as stable as graphite, and so its heat of formation is a little bit higher than 0. Can you think of a really unstable form of carbon? Maybe liquid? What about gas? A gaseous carbon would not be stable at all. So its heat of formation puts it way up here. Remember, higher is less stable, so it has a really big heat of formation. So the heat of formation tells you how much enthalpy or energy is stored in that substance. There's a lot of energy stored in carbon as a gas. It's not very stable. So if the reference form is always defined as 0, is it possible to have a compound with a negative heat of formation? Well, it is possible for a compound. For the element, 0 is the most stable form, so they're not normally negative, but for a compound they definitely can be. And the way it works for a compound is that you have to consider the reaction to make that compound from its reference form elements. So see, here we have carbon and hydrogen in their reference most stable forms, and in this reaction we are making CH4 gas. The change in enthalpy for this reaction is -75. It's an exothermic reaction. So the heat of formation of CH4 is -75 kilojoules. Let's look at the diagram for this. So carbon and as graphite and hydrogen gas, they're both reference forms, so their heats of formation are 0. So that's where our 0 is. And now if CH4's heat of formation is negative, that means it's down here. And remember, lower on an enthalpy diagram means more stable. So in this case, CH4, the compound, is more stable than the elements that it's made from. And this is typical. Compounds are often more stable than the elements they're made from. That's one reason that they exist.